Hello everyone. In this video, we are going to discuss about this chapter sets from class 11 Maths. See, we will be discussing about the set and the representation of sets in this video. And the other topics will be discussed in the other videos which will be available in the playlist. So, first let us see what is a set. See, a set is a well-defined collection of objects. So, what is the difference between collection of objects and well-defined collection of objects? You see, a collection of objects is well-defined collection in the sense that we can definitely decide whether a given particular object belongs to a given collection or not. That is, for example, if you take the collection of, the set of or the collection of rivers of India, we can say that the river Nile does not belong to this collection, right? And the river Ganga does belong to this collection. So we can say that it is a set. That is, the collection of rivers of India, that is a set. Now, if you consider the collection of five most renowned or famous mathematicians of the world, you see that is not a set. See, this is not a set. The collection of rivers of India, it is a set. But the collection of five most renowned mathematicians of the world, that is not a set. Why? Because it is not a well-defined collection. Okay, see, for a collection to be a set, that must be well defined. Because here you see, this is not a set. Why? Because the criterion for determining a mathematician as most renowned may vary from person to person. So this is not a set. Now, if you consider the collection of fruits, it is a set. Why? Because we can say that apple is a fruit. And chili that does not belong to this set. Chili is not a fruit. So it is a well-defined collection. So collection of fruits, that is a set. Now, if you consider the collection of top 5 sweetest fruits, that is not a set. Why? Why? Because for some people, mango, pineapple, papaya, grapes, cherry will be the top 5. But for some others, strawberry, peach, watermelon, orange, dragon fruits, etc. will be the top 5. So, it is not a well-defined collection. So, it is not a set. See, sets are usually denoted by capital letters. That is capital letter A or B or C, X, Y, Z, etc. Now, the elements of a set, that is usually represented by small letters. Small letter A, B, C, X, Y, Z, etc. Now, let us see a few examples of sets. A few examples of sets used in mathematics are shown here, given here. You see, this capital letter N, that is a set of all natural numbers. So, the set of all natural numbers, that is represented with this capital letter N. So, set of all natural numbers means which are the elements of that set? 1, 2, 3, 4, etc. Okay. Now, the set of all integers, that is represented by capital letter Z. Okay, that is set of all integers means there can be negative values, 0, positive values, etc. So, we can write minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. Okay, now capital letter Q, that is used to represent the set of all rational numbers. See, what is a rational number? Rational number is usually denoted by this P by Q. That will be in P by Q form, fraction. Okay, where this Q is not equal to 0. And you see, when you divide this P by Q form, now when you divide this, you will be getting a result. And that result that will be in decimal form, which may either a terminating decimal or a repeating decimal. That can be considered as a rational number. For example, you see, if you consider 1 by 2, that is a rational number. Because this is in P by Q form and Q, in the place of Q, you have 2 which is not equal to 0. Okay, and you see when you do this 1 by 2, you will be getting the result as 0.5. It is a decimal, it is a terminating decimal. Okay, it is not a repeating one. Repeating one is also okay, but that should be like, you see, if you consider a number which is like 0.55555, etc., that is also a rational number because this is a repeating decimal. Okay, but if you consider a number which is root 2, this is not a, this is not a rational number, it is an irrational number. Why? Because when you find the value of root 2, you will be getting it as 1.4121, etc. That is not a repeating decimal. So root 2 is not a rational number. Okay, so set of all rational numbers, that is represented by capital letter Q. Okay, so you see 0.5, 1 is a rational number because 1 can be written as 1 by 1. Minus 2 is a rational number because minus 2 can be written as minus 2 by 1. Okay, minus 5.55, etc. And you see 0, that is also a rational number because you see 0 by 1, that is 0, it is in P by Q form, but Q, which is 1, not equal to 0, so 0 is a rational number. Alright, now capital letter R, that is used to represent the set of all real numbers. Okay, that is rational numbers plus irrational numbers, that will give you, that will give you the real numbers. Alright, now the set of all positive integers, that is represented with Z plus. That is, you have to take 1, 2, 3 for all positive numbers. That is, if you consider all integers, that can have minus values. Okay, but set of all positive integers, so it can have positive values only. So plus 1, 2, 3, 4, 5, etc. And the set of positive rational numbers, that is denoted by Q plus, capital letter Q plus. That is, for example, 0.5, 1 by 2, 1 by 3, 1, 2, 3, etc. These are positive rational numbers. They are represented with capital letter Q plus. Okay, then R plus is used to represent the set of positive real numbers. Okay, they are real numbers but positive real numbers. Okay, see, when we consider real numbers, it can have negative values as well. But when you consider positive real numbers, you can take 2, 5.5, root 2, everything that comes under this real number set. So, you have to consider positive values only. Now, if small letter a is an element of the set capital letter A, we say that A belongs to capital letter A. We use a Greek simple epsilon. Okay, we use a Greek simple epsilon which is used to denote belongs to. Okay, so if small letter a is an element of capital letter A is the set, then we write it as A belongs to A. Okay, now let capital letter V represents the set of vowels in English alphabet. We know that A, E, I, O, U, these are the vowels in English alphabet. So, if we represent the set as capital letter V, which has these elements in it, okay, so we can write it as, you can say that small letter A is a vowel, so it is in the set V. So, we can say that A belongs to the set V. Okay, see, E is also an element of V because E is a vowel. So, you can write small letter E belongs to capital letter V, which is the vowel. Now, if small letter B is not an element of the set capital letter A, we say that B does not belong to A. And we write B does not belong to, no? So, does not belong to is represented like this. This is for belongs to. Then a cut like this. That is a line like this, a cross like this. Okay, so B does not belongs to set A. Okay. That is, for example, we have a set of vowels here. We know that A, E, I, O, U, these are the elements in the set of vowels V. So, we can write the letter C, it is not a vowel, so it is not an element of the set V. So, you can write C does not belongs to V. Okay, now let P, capital letter P, be the set of prime factors of 30. Okay, let P be the set of prime fact. See, what are the factors of 30? Factors of 30, 30, 1, 2, 3, 5, 10, 6, 15. These are actually factors of 30. No, 30 into 1, 30, 1 into 30, 2 into 15. Okay, 3 into 10, 5 into 12. No, not 12. 5 into 6, 10 into 3, 6 into 5. Right. Then 15 into 2, 30. So these are actually factors of 30. Now what about the prime factors of 30? 1. Okay. And you see 2, 3, 5. These are the prime factors of 30. See, the prime number is a number that can only be divided by itself and 1 without remainders. Here you see 3, that is an element of P, because P is the set of prime factors of 30 and 3 is a prime factor of 30. So we can write 3 belongs to P. Okay, now we can write the number 15 is not an element of P, because you see P is the set of prime factors of 30. 15 is a factor of 30, but 15 is not a prime factor. So 15 does not belongs to the set P. Now let us see how to represent a set. There are two methods of representing a set. One is a roster form or tabular form. The second one is set builder form. So let us see what is a roster form and how can we represent a set in or the elements of a set in roster form. You see, in roster form, all the elements of a set are listed. The elements are being separated by commas and they are enclosed within braces. Okay, these things are actually called as braces. So the elements will be separated by commas and the elements are enclosed within braces. So let us see some examples for a set which is expressed in roster form. The first one, the set of all even positive integers less than 7. So it must be an integer, it must be a positive integer, it must be an even positive integer and that must be less than 7. So which are the elements? 2, 4, 6, no? 2 is an even positive integer which is less than 7. 4 is an even positive integer less than 7 and 6 as well. Okay, so in roster form that set is represented like this. You see the elements are separated by comma and they are enclosed within braces. Now the set of odd natural numbers is represented in roster form as like this. That is 1, 3, 5, 7 all are odd natural numbers. And you see here I have used 3 dots. Why? Because the list of odd natural numbers continue indefinitely. That's why. Okay, now the set of all natural numbers which divide 42. So in roster form we will write like this: within braces all the elements, that is all the natural numbers which divide 42 are listed here separated by comma. Okay, you see 1 into 42, 42, 2 into 21, 3 into 14, 6 into 7, 7 into 6, 14 into 3, 21 into 2, 42 into 1. So all these are the natural numbers which divide 42. Okay, that is 42 divided by 1. Right, 42 divided by 2, you will get 21. 42 divided by 3, you will get 14. Okay. You see, in roster form, the order in which the elements are listed within braces, that is immaterial. That is, the order of listing the elements has no relevance. So here the set of all natural numbers which divide 42 are listed here within braces separated by comma like this in roster form. You can write or you can express the same set by like this as well. You see all these elements are here, but the order is not the same as this because the order of listing the elements has no relevance in roster form. In roster form, an element is not generally repeated. That is, in roster form, all the elements are taken as distinct. That is, in roster form, an element is not generally repeated. That is, for example, if you consider the set of letters forming the word principal. So you see, in roster form, we can write it as within braces Princ. Then you see Princ. Then after that we have I and P, that is not written here. Then AL, that is written here. So why I haven't written this I and P here? Because already we have I and P here. So that is, if I'm writing again that I and P, that will be in the repeated form. No, so it should not be. Generally the element is not repeated in roster form. So no need to write this I and P again here. Alright. You can write the set in roster form like this as well, because the order is not important. And you see the order, the set of letters forming the word school, that can be in roster form, that can be represented like this. S, C, H. You see O is repeated, so only one O is needed. Then L. Okay, so this is how we express or we represent a set in roster form. I hope it is clear to you. Now, let us see what is a set builder form. You see, in set builder form, we describe a set by stating the conditions that its members must satisfy. That is, in this form, all the elements of the set possesses a single common property which is not possessed by any other element outside the set. Let us see some examples to understand what is a set builder form. So you see, for example, let us consider the set of vowels in the English alphabet. In roster form, we write it as within braces separated by commas, we write it as A, E, I, O, U, right? And in set builder form, we write the set of vowels in the English alphabet like this. We read it as set V is a set of all X such that, this colon, this is such that. Okay, X is the element of the set. You can use Y, Z, any other letter here, that is the element of the set. It is followed by a colon here, that is for such that. Okay, so we read it as set V is a set of all X such that X is a vowel in English alphabet. Okay, see, X is the element of the set. It is followed by a colon, that is such that. And after the colon, we write the property of the elements, and the all description is enclosed within the two braces. Okay. Now, let us see the set of all natural numbers which divide 42. We have already seen that in roster form, we will write like this. And in set builder form, we write like this. And we read it as set A is a set of all X such that X is a natural number which divide 42. Now, if you consider the set of all odd natural numbers, then we will, in roster form, we will write like this within braces separated by comma, 1, 3, 5, then the 3 dots are there because, there can be 7, 9, etc. Okay, and in set builder form, we will write like this, set C, it is a set of all Z. Okay, Z is the element of the set. So, set C is a set of all Z such that set Z is an odd natural number. Okay, now you see, if you consider the set A, we read it as set A is a set of all X such that X is a natural number and 3 less than X less than 10. Condition is there, okay. Now, that is, set A is a set of all X such that X is a natural number and X lies between 3 and 10. So, what are the elements of the set? The elements of the set are 4, 5, 6, 7, 8, 9. Because the X is greater than 3 but less than 10, it is a natural number. So, these will be the elements. So, in roster form, we will represent it like this. So, in this video, we have discussed about the set and the representation of sets, that is a roster form and the set builder form. I hope it is clear to you. Thank you.